Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 156, using Mohr circle, determine for the area indicated the orientation of the principal centroidal axis and the corresponding values of the moment of inertia. So here's the figure. Let's divide for our solution. Let's divide this area into the following manner. Vertical line here and there. So that this area would be zero point 0.8. 1.3 minus zero point 0.5 is zero point 0.8 times 1, so zero point 0.8. The location of the centroid from the left edge, which is the y-axis, from the left edge is the original xy axis. The y-axis is zero point 0.4 plus zero point 0.5, so zero point 0.9. Then its centroid from the bottom is 5.3 minus half of 1, so 0 0.5. 5.3 minus 0.5, 4.8. This is area 2.5 by 5.3, so that's 2.65 inches square, the area. And this one, 3.6 minus zero point 0.5, 3.1. 3.1 times zero point 0.5 is 3.1 divided by 2, 1.55, the area. So its centroid, by the way, for this area, the centroid is from the left, 0.25, down half of 5.3, 2.65. For this area here, 1.50, 3.65, 3.1 divided by 2, 1.55, plus zero point 0.5, 1.65 from the left edge, 0.25 from the bottom edge. So Ix, we have to transfer this, the moment of inertia of this to the bottom. So Ix equals, with respect to the centroid, zero point 0.8 times 1 cube over 12, then plus area 0.8, 4.8 square, because the distance of the centroid from the x-axis is 4.8, from the bottom axis is 4.8 square. For this one, rectangle with respect to the bottom, so bh cube over 3. Base is 0.5, height is 5.3, cube divided by 3. And for this area here, base is 3.1, height is zero point 0.5, so 3.1, zero point 0.5 cube over 3 also, because it is with respect to the base. So 3.1 times zero point 0.5 cube over 3. Ix therefore is equal to 43.44 inches to the fourth, and we equate that to I bar x plus area, which is 5 times 2.25 square, because barred y for the entire area is 2.25. Remember, Ix is I bar x plus area barred y square, and barred y is 2.25. By the way, the area is 5 because it is zero point 0.8 plus 2.65 plus 1.55. So 1.55 plus 2.65 is 4.2. 4.2 plus zero point 0.8, so 5 square units, that's the area. I bar x therefore is equal to 18.128 inches to the fourth. Likewise, I bar y, we have to transfer this. Quantity 0.8 cube times 1 over 12 plus area 0.8, then barred x is 0.9 quantity square. The distance of the centroid of this area from the left is 0.9 quantity square. For this it is just 0.5 cube times 5.3 over 3. Then for this area, we have to transfer again because the centroidal axis is here and this is the left edge. So 3.1 cube times zero point 0.5 over 12 plus area 1.55, barred x is 2.05 square. 2.05 is 1.55 plus zero point 0.5. So 2.05 square, where 1.55 is half of 3.1. Remember, this is 3.1. Divide by 2, 1.55 plus zero point 0.5, so 2.05 square. Iy is equal to 26 over 3 inches to the fourth. And to solve for I bar y, 26 over 3 equals I bar y, area is 5, then barred x is 0.912 quantity square. So barred x is from the centroid to the left edge 0.912. 0.412 given in the figure plus zero point 0.5, so 0.912. Take note that these are given, and even if you verify that barred x is really 0.912 and barred y is 2.25, you can do that. The total area is 5 as a whole. So let's not make it a problem because it is given in the problem already. So I barred y is equal to 4.508 inches to the fourth. Then P product of inertia xy with respect to the left and bottom edges is since all areas are rectangular with respect to the centroid 0, so the only component of product of inertia would be the area barred x barred y part. So for this area here, 0 plus zero point 0.8 barred x 0.9 barred y 4.8, remember. For this area here, with respect to the centroid 0, area 2.65 barred x 0.25 barred y 2.65. Then for this area here, with respect to the centroid 0, area 1.55 barred x 2.05 barred y 0.25. So 0 plus 1.55, 2.05, 0.25. So computing, product of inertia is 6.006 inches to the fourth. That is with respect to the left edge and bottom edge axis. Then we compute P barred xy. 6.006 equals P barred xy plus area 5 barred x 0.912, 0.412 plus zero point 0.5, barred y 2.25. So product of inertia with respect to the centroidal axis with respect to this axis here through C is negative 4.254 inches to the fourth. We then plot Ix, which is I barred x, which is 18.128, and comma negative 4.254, and the other partner is I barred y 4.508, then the negative of negative 4.254, which is 4.254. Then we then imagine that each grid is 2 inches to the fourth, 2, 4, 6, 8, 10, 12, 14, 16, 18.128 somewhere here, and negative 4.254 would be here as shown. So this is the axis, x-axis through the centroid, x-axis through the centroid. Then the other one is 4.508, then positive 2.454 somewhere here. Then we connect the 2 points with a straight line representing the diameter of the Mohr circle. So this is the x and that's the y. Then the circle circumscribing this diameter. And this is the center. The distance of the center from the product of inertia axis is 18.128 plus 4.508 divided by 2, or the average moment of inertia, and that is equal to 11.318 inches to the fourth. Since this is the x-axis, this is the principal axis where we can have the maximum moment of inertia, and the rotation from the x-axis is 2 theta. And this is the radius of the circle, and the distance from here up to the center is this leg of this right triangle, and it is 18.128 minus 11.318, and that is 6.81. Then this is I max, this is I minimum, I barred minimum because it passes through the centroid, Then for Imax, it is just 11.318, the coordinate of the center of the circle, then plus the radius. For minimum, coordinate of the center 11.318 minus the radius, where the radius is square root of 6.81 square plus 4.254 square. The radius is equal to 8.029 inches to the fourth. Then tangent of 2 theta is equal to 4.254 over 6.81. 2 theta is 31.99 degrees. Therefore, theta is 31.99 over 2, 15.995. So let's make that 16 in our final answer later. So we have here I bar max, which is equal to center 11.318 plus radius. By the way, it is here on the line OA, and this angle is theta 1, theta P1 or theta 1, or just call that theta. Then the other axis where it contains the minimum moment of inertia is the CB axis, that one. So this is the axis where the moment of inertia is minimum. So I bar max is equal to 19.35 inches to the fourth, and I barred minimum is 11.318 minus the radius 8.029. So I barred minimum is equal to 3.289 degrees. So I bar max is located from the x-axis, rotate counterclockwise by an amount theta, and theta A is equal to 16.00 degrees. So we can locate the axis where moment of inertia is maximum. Then since the angle between them is 90 degrees, so plus 90 in counterclockwise direction, that's the positive direction. That's theta B. 16 plus 90 is 106 degrees. So that's it for this problem. I hope that you were able to follow the explanation and the solutions, because Mohr circle is after all a geometric approach that we don't need to memorize formulas from transformation equations of moment of inertia. And we just plot it here, and we just use plain trigonometry, and by just looking at the figure you can set up the formula for maximum and minimum, or for even moment of inertia with respect to an axis, let's say I sub u, I sub v, and the product of inertia there.